Assalamu alaikum students. Hope all of you are fine by the grace of Almighty Allah. Today I will start a new chapter, chapter 7, which is about chemical reactions. Different types of chemical reactions are going on around us. But before discussing about the chemical reactions, we have to learn about the changes in matters. Okay? In our surroundings, there are mainly two types of changes. One is physical changes and another is chemical changes. And a chemical substance is composed of one or more than one elements. And all chemical substances have a certain percent composition of its elements. We have already learned about that. Okay, and sometimes changes occur only in the physical states, leaving their composition, their chemical composition unchanged, and that means leaving their own identity, chemical identity unchanged. And these types of changes are known as physical changes. That means we can define the physical change as physical change is a usually reversible change. Okay, reversible change in the physical properties of a substances. Okay, only in the physical properties of a substances. What are the physical properties of any substance? We know about that: the melting, the boiling, freezing of any substance, and the strength or density of any substance, color, volume, size, shape, etc. are known as physical properties. And physical change, during the physical change, only the physical properties of a substance can be changed. And in that case, no new compound, no new chemical substances, no new chemical spaces form. Okay, and look at this portion. This is the important reversible change. Okay, it's a reversible change. That means it can be undone. Okay, often it can be undone if external energy, some energy is input. That means it's a reversible change. Okay, and if we explain it with an example, it will be more clear. Here, this is a change for water. Okay, water, this represents the solid form. Okay, that means solid water. Solid water, that means it's ice. Okay, ice. When we place a piece of ice in an open place, okay, open air, then the ice cube absorbs heat and turns into liquid water. Okay, absorbs heat from the surroundings and turn into liquid water. And this liquid water on heating absorbs heat. If we heat it up to 100 degrees Celsius, then the water vapor is produced. Okay, that means liquid water starts to vaporize and water vapor is produced. And in that case, the physical state of water in every case, okay, changed. But the chemical formula, okay, the chemical formula of water for all these three states are the same. Okay, which is H2O, H2O, H2O. And that means the composition, the percent composition of hydrogen and oxygen, and in all the three states of water are the same. And also in this water molecule, two hydrogen for these three cases, two hydrogen atom and only one oxygen atom are present. Okay, and in that case we found no new compound, no new chemical substance is or are formed, and that's why this change is known as physical change. Okay, and that means this type of, we can give more some example. Think about breaking of a glass bottle or glass. Okay, and then the glass, the chemical properties of the glass and the chemical properties of the glass pieces. Okay, after breaking, the glass pieces are the same. Okay, and we can also take the evaporation of alcohol. We know alcohols are volatile substances. They can easily, at room temperature, they can evaporated. Okay, and then also the alcohol turns into vapor alcohol. Okay, liquid alcohol turns into vapor alcohol. There is also no chemical change. This change is known as physical change. And also, if we take dry ice, we know about that dry ice. What is dry ice? The solid carbon dioxide. Okay, solid carbon dioxide. And when we place a solid carbon dioxide in an open place, in an open air, then this also can churn dry ice. Okay, turn into carbon dioxide gas. Okay, and for that case, this is solid to gas. Okay, this process is known as sublimation. Okay, sublimation, and this is also a physical change. Here is also in dry ice, the chemical formula is CO2 and gaseous carbon dioxide also CO2. I think physical change is clear to you. But sometimes changes occurs due to heat, pressure and contact with other substances. New substances are produced with a new chemical formula and through changes in the percent composition of the existing elements of the substances. But in that case, new substance with new chemical properties are produced, and we know this is occurs, this chemical change occurs by chemical reactions. Mainly chemical reactions can produce new compound with new properties. That means chemical reactions is mainly responsible for chemical changes. And we know in chemical reactions new bonds are formed in products. New bonds are formed in products, and old bonds are breaking in, which present in reactants. Okay, and such as if we take our natural gas. Okay, our natural gas, our cooking gas, the main component of our cooking gas is methane. And when methane is burnt with oxygen, then it produces carbon dioxide and water. Okay, and methane is gas, oxygen gas, carbon dioxide gas, and water also in vapor form. And in that case, we can easily observe that methane CH4 with the molecular formula O2, the molecule of oxygen, reacts with each other and produce CO2, carbon dioxide, and H2O. And these two are the products for this chemical change reaction, and these are the reactants. And we can easily observe that the molecular formula of carbon dioxide and H2O, water molecule, are totally different from CH4, methane and O2. And that's why the chemical properties of carbon dioxide and chemical properties of water is totally different from the reactant molecules. Okay, methane and oxygen. And this change is known as chemical change, and this is also known as a chemical reaction. Okay, by doing a chemical reaction, we can change a compound or substance chemically. Okay, and this is naturally this cannot be undone easily. Okay, and the only way to reverse these chemical changes is to apply another chemical reaction. Okay, we can get this methane and oxygen from this carbon dioxide and water if these are reacted, these two are reacted in a chemical reaction. Okay, and I think chemical change and physical change are totally clear to you, and the next is our next topic is the chemical reaction, types of chemical reaction. There are many types of chemical reaction always happens in our around our surroundings. Okay, and mainly there are our chemical reactions are classified depending on three main bases. Okay, one is direction of the reaction, one is direction of the reaction, another is heat change of the reaction, and other is number one is direction, two is heat change of reaction, and number three is electron transfer. Okay, and according to direction of reaction, the reactions can be classified into two types. One is reversible reaction and another is irreversible reaction. And heat change, according to heat change of reaction, there is only the chemical reactions are two types. One is exothermic, another is endothermic reaction. And according to electron transfer, there is also two types of reactions. One is redox reaction and another is non-redox reaction. At first, according to direction of reaction. Okay, what is irreversible reaction? The irreversible reaction is a reaction which proceeds only in one direction. Okay, the irreversible reaction which proceeds only in one direction from reactants to products. Okay, from reactants to product, and the products don't have any tendency to reform the reactants. Okay, and take an example, then it would be more clear to you. If solid carbon reacts with oxygen, burns with oxygen and produce carbon dioxide gas. Okay, carbon dioxide gas. But as carbon dioxide gas is produced, this carbon dioxide gas cannot be converted back into the carbon and oxygen with the same method and conditions. Okay, if we get the condition is same, then this conversion from carbon dioxide to carbon and oxygen is not possible. That's why this is an irreversible reaction. Okay, this reaction proceeds only in one direction, from left to right direction. Okay, that means only the forward reaction is possible, but the backward reaction is not possible. That means product to reactant is not possible. This types of reaction is known as irreversible reaction. Another example of irreversible reaction is decomposition of quicklime. Calcium carbonate, okay? Calcium carbonate, solid calcium carbonate, which is known as quicklime. If we heat this calcium carbonate in a open container, okay? Of course, in a open container, then it produce calcium oxide, solid calcium oxide and carbon dioxide gas. And as the products are produced, the carbon dioxide gas is removed from the reaction container, reaction vessel, okay, because this is a gas, and this reaction is occurred in a open container. That's why the product will be eliminated from this reaction vessel. Then the further reaction, the backward reaction is not possible, because one of the reactant is, for the backward reaction, this calcium oxide and carbon dioxide are the reactants, okay, but one of the reactant is missing there, okay. That's why the backward reaction is not possible, and so this is a the decomposition of calcium carbonate is a irreversible reaction, okay. But the same reaction can be considered as a reversible reaction. Example of reversible reaction, okay, how? We have to know, okay. Then we have to know about the reversible reaction, okay. Reversible reaction, and the definition of reversible reaction is: reversible reaction is a reaction in which the reactors react to form products, and the products have the tendency to react and reform the reactants, okay. In a reaction in which the reactants react to form products, okay. Give an example, which is nitrogen. We can take nitrogen gas and hydrogen gas. Nitrogen and hydrogen gas reacts with, here I use this sign, okay. This is the reversible sign, okay. Half arrow to half arrow represent, the arrow marks represent the reversible sign, okay. And nitrogen reacts with hydrogen gas and produce ammonia gas. The molecular formula of ammonia, NH3, ammonia gas. And we can balance this. This is 3, this is 2. Okay. That means, and this process is known as Haber process. Okay. The ammonia, the industrial process of ammonia production, and very important industrial reaction. And that means we can say this reaction like that: nitrogen and hydrogen reacts with each other in a 1:3 ratio and produce ammonia gas. And the condition is in presence of iron dust and 200 to 250 atm pressure and 450 degrees Celsius to 550 degrees Celsius temperature. Okay, and in this reaction, this is a reversible reaction. Why? In this reaction, nitrogen and hydrogen reacts and form ammonia. And as the ammonia is formed in the container, at the same time this ammonia decomposes to produce nitrogen and hydrogen at the same condition. The condition is maintained the same. Okay, at the same condition, simultaneously at the same time, ammonia decomposed and produced nitrogen and hydrogen. Okay, that means in a reversible reaction, two reactions continue simultaneously. Okay, one is forward reaction and another is backward reaction. That means in one reaction, reactants converts into products, which is known as forward reaction. Okay, this reaction is forward reaction, and this is indicates the forward reaction, and this opposite half arrow marks indicates the backward reaction. Okay, backward reaction. That means what is the definition of backward reaction? In the reaction in which the products react and reform the reactant molecules is known as backward reaction. That means in a reversible reaction, two reactions continue simultaneously. Okay, two reaction takes place simultaneously, and it is impossible. The reversible reaction never go to the completion. Okay, never go to the completion if it occurs in a closed vessel. Okay, in a closed vessel. Another example, our quicklime example. Okay, we have to remove this. Now we put this okay, heat calcium carbonate, calcium oxide and carbon dioxide gas. But if this reaction occurred in a closed vessel, okay, for irreversible reaction we use an open container, and for that now we have to use a closed vessel, closed container, and then this reaction is considered as will act as a reversible reaction, because this gas, one of the main product, cannot be removed from the vessel container, and that's why this calcium oxide and carbon dioxide reacts with each other and produce calcium oxide. So in a closed vessel, this is a reversible reaction, and in a reversible reaction, 100% product, obtaining the 100% product is not possible. Okay, that means some portion of product always continuously converts into the reactants. Okay, and that's why if any irreversible reaction is taking place in a closed vessel, closed container, then it never go to any completion. Okay, 100% product is not possible to obtain. And this was about the reversible reaction and irreversible reaction. Another important example of reversible reaction is esterification reaction. Okay, that means ester formation. Okay, means ester formation. Ester is a very common and important organic compound. Okay, very important organic compound, ester, and it is produced from another important organic compound, and these all name and the formula are new for you, but this is included in your syllabus. You will learn about that at chapter 11. Okay, now try to understand and try to remember that. For the ester formation, the reactants are acid, fatty acid, organic acids. Okay, one of the reactant is organic acid. This is known as ethanoic acid. Okay, ethanoic acid. Okay, the main component of vinegar. We are known about that. Okay, and ethanoic acid and ethanol, alcohol. Okay, it's a very popular alcohol. Ethanol. And then in the presence of HCl, that means acid, maybe sulfuric acid. Okay, and that means the medium of this reaction will be acidic. that means acetic acid or ethanoic acid reacts with ethanol in presence of HCl form ester. Ester. The reaction mechanism, shortly I can explain it. From this acid, this OH part, and from this H will be removed. Will be removed as water. Will be removed as water. That means the water is one of the product, and the other portions will be attached. Okay. Then O, CO, O, H3, O, CH2, CH3. Okay. And this is the ester. The name of this ester is ethanoate. Okay, and this ester formation is also reversible reaction. As the product ethyl ethanoate is produced, the backward reaction will be started. Okay, this ethyl ethanoate further reacts with water and produce ethanol and ethanoic acid. So for this reaction also 100% product is not possible to obtain. Okay, and our few examples are mentioned in your book, hydrogen gas and iodine. Okay, this is also reversible reaction to hydrogen iodide. Okay, you have to practice and you have to try to remember these reversible reactions. And maximum in our surroundings, maximum reactions are reversible. Okay, maximum reactions are reversible in nature, but for some reactions the rate of backward reaction is so small, so slow. That's why these appear to be a irreversible reaction. Sorry. Okay, that means if the rate of backward reaction is so slow, then this reaction appears to be a irreversible reaction. That means the amount of product dissociated and converts into reactants, this rate is so slow. And students, that's all for today. Assalamu alaikum.